I'm Jeff Keeter. I'm the president of the George Marshall Institute. It's my pleasure to welcome you to this installation of the Washington Roundtable on Science and Public Policy. That's a continuing series of the Institute designed to bring together the scientific and technical community with economists and policymakers and others to discuss issues of importance, of which climate change certainly has been a long-standing theme of ours. Today's discussion is on the social cost of carbon. That's a metric that's being used by the regulatory community to justify a host of emission control efforts that are presently percolating their way through the Environmental Protection Agency. Like any regulatory standard, in my opinion, it's rife with its validity, rather, is dependent upon your acceptance of its assumptions, the data that drives those assumptions, as well as how you think folks will react to it once it's in place. So our discussion today really is on the data and the assumptions behind the justifications for the social cost of carbon as it's presently being considered at the Environmental Protection Agency. Pleased to have this panel of experts here to talk to you today about this. David Kreutzer from the Heritage Foundation is on his way in, but he is a research fellow there focused on energy and environmental policy. We'll drop him in whenever he arrives. But kicking us off today will be Dr. Pat Michaels. He's the director of the Center for the Study of Science at the Cato Institute. He's the past president of the American Association of State Climatologists and was the program chair for the Committee on Applied Climatology of the American Meteorological Society. He was a research professor of environmental sciences at the University of Virginia for more than 30 years, a frequent commentator on these types of issues. Dr. Roger Bezdek, the president of Management Information Services Incorporated, will follow. He's the author of a recent study on the social cost of carbon, which I highly commend to you. He'll be briefing those results today. He has 30 years of experience in consulting and management affairs in the energy, utility, and environmental areas, serving private industry, academia, and the federal government. He's the founder and president of MISI, an energy and economic research firm. He has served as senior advisor on energy in the Office of the Secretary of the Treasury, as the U.S. Energy Delegate to the European Community and NATO, and a consultant to the White House federal and state and government agencies, as well as many other organizations. Thank you both for being here. Pat?
You know, I have to commend you all for coming out. First of all, this seems like an incredibly and impressively boring subject. And it's in the regulatory weeds, and it's also very important, because the social cost of carbon is used to justify regulation on the putative basis that, are you going to go to the slide? There we go. On the putative basis that we are actually saving you all tremendous amounts of money by putting in these minuscule emissions restrictions that are justified by this thing. I run something called the Center for the Study of Science at the Cato Institute. It's been around for about a year. We are interested in exactly this particular type of problem, which is how we get such horrific regulation justified by, quote, science, end quote. And it results from the incentive structure for science and all kinds of perverse things that happen when science becomes a public good with monopoly funding from one provider. That would be the people in this building. Okay, so just to give you an idea of the kind of people that we're bringing on, in the last 6 months we brought on Richard Lindzen from MIT, Ed Calabrese, who is very, very important in the regulatory world from University of Massachusetts, and now Terence Keeley, author of the Bible on the economic loss of scientific research. Okay, let's go to the next image. On the social cost of carbon. I submitted comments along with Paul Knappenberger, who works with me at Cato. This is sort of the key finding. The determination of the social cost of carbon is discordant with the best scientific literature on equilibrium climate sensitivity. In other words, it's way behind the times. And it knows it, but it simply decided to go forward. And the fertilization effect of carbon dioxide, you put CO, in high school, CO2 plus H2O yields CH2O. That's the simple equation of photosynthesis. You increase the reactants on one side, you get more out on the other side. Shocking. Turns out you get a lot more out than you might have thought. And that simply was not factored in. And finally, there are problems with the so-called integrated assessment models. that were used to determine the social cost of carbon. We'll talk about those briefly for a couple of minutes, and I think you might actually wind up agreeing with me. Our conclusion is that the OMB, Office of Management and Budget, this is what we were commenting on, should not just revise the current determination of the social cost of carbon, but suspend its use in all federal rulemaking. It is better not to include any value for the SCC in cost-benefit analyses than to include a value which is knowingly improper, inaccurate, and misleading. Aside from that, we have no strong feelings on this subject. Next image, if we could. This invisible image, I was kind of hoping we were going to have a bigger screen, so imagine you can actually see this. This is what is at the guts of the climate component of the social cost of carbon. It's something called the equilibrium climate sensitivity. That's how much warming you expect to get for doubling atmospheric carbon dioxide, an arbitrary doubling. And here's a series of papers that I would call paradigm-defining papers from about 5 to 10 years ago. And just to make sure that they were behind the times, the integrated assessment methodology uses a calibrated sensitivity by Rowe and Baker, which has about 2.5 degrees maximum frequency, but this huge fat tail on the right side. And the fat tail is the excuse, okay? The fat tail is, oh my God, it could be worse than we thought. Well, if you know anything about science, particularly environmental science, it's always worse than we thought, no matter whether it is or it's not. So the fat tail becomes the excuse for regulation. Too bad this is so remarkably behind the times. Let's go to the next image if we could. Since January 1st, 2011, a large number of papers have appeared in the refereed scientific literature. Okay, this is not, Bozo's website or anything like that. These are 16 separate experiments, and the equilibrium climate sensitivity in these is running somewhere in the average value of about 2, but note the 95% confidence limits for all these, and here is what's used for the social cost of carbon calculation. This is SCC calculation. This is the modern literature. I did not include in here the first of these sort of low sensitivity papers, which I published 10 years ago, and that caused all kinds of bad things in ClimateGate. Like we don't want the editor to even have a job who allowed this paper to go in and such like that. Well, a sensitive field, okay? Don't know why. Anyway, bottom line, the calibrated Rowe and Baker functional form, that's what's on the previous slide, used by the interagency working group is no longer scientifically defensible. That's a fact. And one of these days, we're building one of the purposes of our many comments on the social cost of carbon, microwave ovens, refrigerators, toasters, you name it, is to establish a very large record that we hope will ultimately enter into the justification, if you will, or the justifying of a lower sensitivity, lower social cost of carbon. Next image, if we could. The Rowe and Baker distribution has a median value of 3 degrees C, and the 5th and 95th percentiles are 1.72 to 7.14 degrees Celsius, doubling, equilibrium warming for doubling. That's a huge number. And seen as the equilibrium number for doubling is pretty close to the 2100 estimate, given the rates of increase that we have in atmospheric carbon dioxide. You understand how fast the planet has to warm up. It's only got 86 years left to go up 7.1 degrees. It hasn't gone up any since late 1996, statistically speaking, so it better get cracking, which is one of the reasons that all these papers have appeared since the beginning of 1911. By the way, there are some scientists who are recognizing that this is falling apart, and they're oftentimes adjusting their sensitivities based upon some principle that usually doesn't apply in global climate policy, which is called reality. The corresponding values averaged from the recent scientific literature are 2 degrees C, median, 1.1 degree on the 5th percentile, and 3.5 degrees on the 95th percentile. A huge difference, a difference between something that is a justifiable regulatory problem and something that, well, maybe doing nothing is the best policy because we seem to become more efficient from market forces. That is what changes between those two figures. Next image. Here's the money show from the scientific problem. Now, this is a very small image. I want you to follow me because I want you to see what is really happening on the surface of the Earth compared to what was forecast to happen. There are 105 climate models that the United Nations used in its most recent report that's been out for about 8 months or so. They have been run many, many times so that you can generate statistical distributions of the ranges of warming or cooling. Sometimes these things actually predict brief cooling trends. So you get the 90 and 95% confidence levels for the model projections. The average value of all the model projections is the solid line here for trend lengths of 10 years. That would mean from 2013 back to 2004, and then 11-year would be 2013 back to 2003. We go all the way back to 1951. So this is the average trend for periods of from 10 to over 50 years in length, predicted by the 105 models from the United Nations. We're using their stuff, okay? Because it turns out their stuff doesn't justify what's going on with the social cost of carbon. The dotted line is the 95th percentile, 95% confidence interval. The sort of grayish one is the 90% or the 10% if you want to think about it. But of course, because we're really only interested in the one side, the cold side of this distribution, you might want to realize that we're actually going to 95 and 97.5% confidence in terms of argument. And guess what? The red line is reality. Well, it's the line that starts out green right here, which means that it's within the 90% confidence bounds for trends back to 1950, et cetera, et cetera, et cetera. But when we get the trend back to about 35 years, all of a sudden it falls below the 90%. Again, this is single-sided, so it's actually better than that. That's the yellow color. And when it gets red, it's below the 95% confidence limit. Hey, you know what? When you test an hypothesis on data, and the null hypothesis, unfortunately, is entertained in the following sense, that the data shows that the hypothesis fails at the 0.05 level, the ethical thing to do, and I chose that word right there, the ethical thing to do is to modify your hypothesis. And it sure as hell is not an ethical thing to use that hypothesis to justify costing the American people tons and tons of money. It doesn't work. By the way, this was presented to the American Geophysical Union last summer, and the only negative comment was, you really shouldn't show this image because it might prevent regulation of carbon dioxide. No scientific claims, no scientific griping, just you really shouldn't show this, okay? Emperor is kind of not wearing a lot of clothes. Next image. Then there's carbon dioxide fertilization, completely ignored by the integrated assessment models. It's either, well, not completely, okay? It's largely ignored in the DICE model and the PAGE model. And it certainly is underestimated. If you want to see how much carbon dioxide is accelerating the growth of agricultural plants, we'll look at the next image, if we could. This is from Craig Idso, very recently. It's from a massive study of the literature. And these are the crops, C4 and C3 crops. Sugarcane, percent biomass change. This is just 300 parts per million increase of CO2. 34%. Corn and maize, that would be 24%. These are all big, big numbers. And they're not really factored in to this discussion. Next image, we're almost done, don't worry. So IDSO found that the increase in CO2 that took place from 61 to 2011 increased global agricultural output by about $3.2 trillion in 2005 constant dollars. That's not a small sum. And if we project forward based upon the UN scenarios that they use, the median emissions scenario, CO2 fertilization would increase the value of agricultural output by $9.8 trillion during 2012 to 2050. This is a huge positive externality that is largely ignored in the calculation of the social cost of carbon. It's a lot of food for a lot of people. Next image. And then, this is my favorite, maybe. There are so many targets and so little time in this horrific calculation that is being used to justify the taking of your money. Well, your money that you don't have anyway, and you won't have, but you get the idea. The Interagency Working Group reports the global value. That's the effect on all the countries of the world of the social cost of carbon. The domestic costs, if you don't do the global thing, they're about an order of magnitude lower than the global costs. Now, how much does this fly in the face of what they're supposed to do? Well, I know that we seem to be rewriting a certain somewhat unpopular law on the fly because it's unpopular. Just let's look at this stretch. This is the OMB Circular A4 regarding regulatory analyses, okay? Your analysis should focus on benefits and costs that accrue to citizens and residents of the United States. Can we be more explicit? Okay? That's like, individual mandate goes in place on January 1, 2013. It's a real statement. Where you choose to evaluate a regulation that is likely to have effects beyond the borders of the United States, these effects should be reported separately. The public, I will conclude, has no idea that the benefits of the proposed regulations on domestic activities that supposedly accrue from incorporating the social cost of carbon are largely conferred upon the foreign nations. Let's hear it for transparency. Why wasn't this put out there? I don't know. Next image. This is the fine print. This is the discount rate that's assumed in the calculations of the social cost of carbon. Now, I'm presuming Dave Kreutzer is coming by, right? So I'm not going to take. Okay, cool. I'm not going to take a lot of time on this, but OMB Circular A94 states that, quote, a real discount rate of 7% should be used as a base case for regulatory analysis, and to show the sensitivity of results, quote, for regulatory analysis, you should provide estimates of the net benefit using both 3% and 7%. Okay, fine. So the higher the discount rate, the less the impact. In fact, if you get it to values that are pretty close to historical values, the impact, and you assume the right sensitivity for CO2, which is probably somewhere around 1.6 to 2 degrees C, something like that, you know what? The cost goes positive. That's right. In other words, it actually is a benefit, but you wouldn't want people to know that. So instead, the Interagency Working Group determined the social cost of carbon using discount rates of 2.5, 3, and 5%. Well, that's not exactly Rosie's scenario. Maybe they're just taking into account the economic pillage that has been visited upon coming decades. Who knows? Next image. Finally, MIT's Robert Pindyck, 2013. I will take this sentence here. What have the IAMs, meaning the integrated assessment models, told us? The answer is very little. The models are so deeply flawed as to be close to useless as tools for policy analyses. Worse yet, precision that is simply illusory, it can be highly misleading. An IAM-based analysis suggests a level of knowledge and precision that is non-existent, allowing the modeler to obtain almost any desired result because key inputs can be chosen arbitrarily. And that is exactly what happened here. There were marching orders. Make sure it costs a lot. So I can stand up in front of a camera and say, this is a great benefit to the American people. Put those numbers in, get it right. Well, it turns out, I think this is a blessing in disguise because there are so many problems with the sensitivity, so many problems with the discount rate, and so many problems with the actual effects by using international versus national. You know what? One of these days, a judge is going to sit up and take notice, and I look forward to that day. Thanks.
Pleasure to be here this morning. I'll be summarizing the results of a study we published last month entitled The Social Cost of Carbon, Know the Social Benefits of Carbon. Next slide, please. I'll be covering some of the topics that Dr. Michaels mentioned. Since he's already discussed that, we'll be going quickly through some of these topics. Then I want to concentrate on looking at the potential benefits of carbon dioxide, and compare those to the cost as is supposed to be done. Next slide, please. All right, the federal government must assess both the costs and benefits of proposed regulations. This is an executive order issued in 1993 by President Clinton. As indicated, the Interagency Working Group first published their social cost of carbon estimates in February of 2010, $22 a ton approximately. In May of 2013, 3 years later, they upped those by 50%. Voila. They've warned us that they're going to revisit these, and I can guarantee you the cost will go up and not down. Now, just as an aside here, this is an official government estimate. Think about if the Bureau of Economic Analysis, the Commerce Department, changed by 50% or 30% the estimate of GDP within 3 years, or the Labor Department changed the unemployment estimate. It's ludicrous. The SCC, the social cost of carbon, is meant to be a comprehensive estimate of climate change damages, and as indicated, it's starting to be used in the development of proposed regulations. However, again, according to federal law, benefit cost analysis is supposed to be used, and to do that, you have to look not only at the cost of something, but also the benefits. That's how benefit cost analysis is done. It's common sense. Next slide, please. Cut to the chase here. Fossil fuels from which carbon dioxide derived, created, and are responsible for the modern world that we live in, all the good things that we currently enjoy. iPhones, iThings, iPads, vehicle transportation, refrigeration, central heating, indoor plumbing, etc. What have fossil fuels done for us recently? They facilitated the industrial revolutions, including the current one going on in the 21st century, created the modern world, advanced technology. Over the past several centuries, global life expectancy has more than doubled, population increased eightfold, real incomes increased by a factor of 11. CO2, of course, also increased. As many studies have found, ours is a high-energy civilization based largely on fossil fuels. Next slide, please. This is just a graph showing what I've just stated, the strong relationship between fossil fuel utilization and modern civilization, health, well-being, wealth, etc. It ain't rocket science. Fossil fuels in the industrial revolutions, 3 of them, as Robert Gordon pointed out, are creating the modern world, and as we'll see in a minute, will continue to do so. Next slide, please. All right, fossil fuels power the world. This chart says it all. Coal, oil, and natural gas currently provide anywhere between 80 and 90% of the world's energy, depending on whose estimates you want to use, and for the foreseeable future, the next 4, 5, or 6 decades at least, will continue to. Next slide, please. Okay, energy is required for economic growth, past, present, and future. Most of the population, most of the growth, and most of the increased world energy use will come from the non-OECD nations, the poor nations, the developing nations, and those nations seeking to be developed in primarily Africa, Latin America, and Asia. Next slide, please. Fossil fuels will remain supreme, again, for the foreseeable future. The EIA, the Energy Information Administration, forecasts that fossil fuels will continue to provide, the next 30 or 40 years at least, 75 to 80% of the world's energy. Next slide. Coal is the major fossil fuel resource. Coal resources, as estimated by the International Energy Agency, are 4 or 5 times the combined energy resources of oil and natural gas. As I like to say to people, coal is the energy source of the past, present, and future. Next slide. Electricity is essential for life, for modern society. This is simply a graph of the UN Quality of Life Index. Shows a very strong correlation between per capita electricity utilization and the UN's Human Development Index. The U.S. National Academy of Sciences identified electrification as the world's most significant engineering achievement of the past century. And a group of experts late last year ranked electricity as the second most significant innovation in the world over the past 6,000 years, second only to the printing press. Next slide, please. Fossil fuels are essential for electricity production. While world energy consumption is growing rapidly, electrification is growing even more rapidly. Both the U.S. and the rest of the world are becoming increasingly electrified. A larger and larger share every year of the world's energy is being comprised of electricity, and coal is currently the world's predominant fuel for electricity production and will remain so according to all forecasts out there. Next slide, please. These are the direct CO2 benefits, direct benefits of CO2, as Dr. Michaels explained. There are estimates provided by Dr. Craig Itzo as part of this project. As Dr. Michaels mentioned, over the past 3 decades or so, it's in excess of $3 trillion. And these come about from the positive influence of CO2 on plant growth and agricultural productivity. Next 30 or 40 years, the estimates are in the range of 9 to 10 trillion. Those are direct CO2 benefits, but they pale in comparison. We're going to be talking about the rest of my presentation, the indirect benefits of CO2. Next slide, please. All right, this is the Federal Interagency Working Group. I won't say much here. They produce these estimates of social cost of carbon. As Dr. Michaels explained, they're deeply flawed. They imply knowledge and precision that are not there. Serious weaknesses. The methodology which employs these integrated assessment models, many assumptions that link human activity and environmental effects, even small variations produce different results, et cetera, and so forth. The bottom line, again, according to distinguished economist Robert Pindyck, is that the IWG SEC estimates are, for policy purposes, essentially useless. I won't have anything much more to say about the SEC estimates, except that in our work, we accepted those as they were. There are serious problems with them. We just accepted those, both the current and their forecasts out to the year 2050. Next slide, please. Hundreds, if not thousands, of major, comprehensive, seminal, peer-reviewed studies link energy and growth over the past 2 centuries. This is simply a truism. There are hundreds and hundreds of very careful studies out there, and it's straightforward, it's obvious. You need energy to grow the modern economy, the modern society. 80 to 90% of the energy we are using is fossil fuels. Energy use and output are tightly coupled, close connection, et cetera, and so forth. Next slide, please. This is just a graph of the relationship between GDP, population, and energy use over the past 100 years or so. Quote, fossil fuels create an economic miracle that has lifted billions of people out of hopeless poverty. More recently, we've seen that going on in China and to a lesser extent India and Indonesia, for example, where over the past several decades, anywhere from 500, 600, 700 million people have been lifted out of poverty. They've been taken literally from the 14th century, living as if they were in the 14th century, to the modern 21st century, almost exclusively using fossil fuels, energy. Next slide, please. This is the graphical relationship between the link between CO2 and the GDP over the past century or so. The CD2 derives from fossil fuel utilization, so we call it the indirect benefits of CO2, the fossil fuel utilization. And again, if you want a modern civilized economy, you want to grow that economy, you require energy, you require fossil fuels. Next slide, please. What we did then is take the normalized per ton value of fossil fuels as expressed in terms of GDP in constant 2007 dollars, because that's what the Interagency Working Group used, and compared for 2010, their estimate, using their estimate of cost with the benefits of fossil fuel utilization, and Dr. Michaels is right, 5 or 3 or 2% discount rates are too low, but we didn't get into that. We just used their estimates as such, and found out that even using those very suspect estimates, when you compare the benefits of CO2, the benefits of fossil fuel utilization, compare those with the cost that the IWG has estimated, the benefits outweigh the costs anywhere from orders of magnitude, anywhere from 60 to 1 to 200 to 1. Now, to put this in perspective, a traditional cost-benefit analysis, benefit-cost analysis, when you've got an investment or a project, you're trying to see if the benefit exceed the cost. You get a ratio of 2 to 1 or 3 to 1. That's great. You're good to go. I mean, you're talking about 60 to 1 or 200 to 1. It's off the charts. In fact, I like to say the benefits of fossil fuel utilization are so large that even the estimated costs of the SEC by the Interagency Working Group are in the statistical noise, literally. Next slide, please. Those estimates were based on the 2013 estimates from the Interagency Working Group. If we use the 2010 estimates, the benefit-cost ratio would be even larger, anywhere from 100 to 1 to 500 to 1. So you get the idea here that the benefits of fossil fuel utilization are so large as to make the cost trivial, even the cost estimated by the Interagency Working Group. Next slide, please. All right, much of the policy discussion is focused on the future, what's going to happen in the future with temperature, with CO2, with energy utilization, and so forth. So we have to look at future emissions, potential cost and impact, prospective policies. So what we did here is took the best available forecasts of economic growth, GDP, fossil fuel utilization, CO2 production, et cetera, then used the estimates made by the IWG, which are out to the year 2050, and compared them. Next slide, please. All right, world GDP forecast. The Energy Information Administration expects that in the reference case, the next 30 years, world GDP will increase by a factor of 3. It's going to triple. Next slide. World CO2 emissions will also increase substantially, but by about 50%. Again, being derived from fossil fuel utilization, which is almost entirely powering that GDP growth. Next slide. GDP, energy, and CO2 will remain closely linked in the future. These are some results of sensitivity analysis. We looked at the EIA reference case, high growth and low growth cases. The relationship is very strong in either case. So once again, world GDP growth is very closely tied, linked, requires CO2 emissions generated by fossil fuels. Next slide. This is a graph of that relationship approximately out to the year 2040. Again, world GDP continues to grow, as so also does fossil fuel utilization and CO2 production. And again, in the future, at least as much in the past, increased energy utilization is essential to pull people out of poverty. Not so much in the developed OECD nations, US, Europe, Japan, but especially in the third world. Again, Africa, Asia, Latin America. In fact, Bill Gates was quoted late last year. You could pick just one thing to reduce poverty, by far you would pick energy. So even the good Mr. Gates realizes the determinant factor in pulling billions of people out of poverty, taking them from the 12th century, if you wish, 21st century, is energy. Next slide. And again, in the future, anywhere from 75 to 80% of that energy will be fossil fuels, according to every comprehensive, legitimate forecast out there. All right, we use the same methodology to look at future benefit-cost ratios. Using the 2013 IWG report, forecast CO2 benefits exceed costs anywhere from 71 to 250 to 1. Again, orders of magnitude. Next slide. Using the 2010 IWG report, those estimates, the benefit-cost ratios, again, are 100 to 1 up to 500 to 1. Again, orders of magnitude. Next slide. All right, we did a number of things in the study, one of which I'll just spend a minute here, what I call scale benefit cost ratios. Admittedly, not all of the energy in the world comes from fossil fuels. Currently, it's between 80–85%. In the future, it'll be somewhere in the range of 75 to 80%. So basically, we took that into account and reduced GDP gradually, or the GDP attributable to fossil fuels by those ratios. Next slide. And this is what we found, that again, as expected, the benefit cost ratios are still extremely large. Using the 2013 IWG estimates, benefit cost ratios are anywhere from 60 to 1 to 170 to 1. Next slide. Using the 2010 SEC estimates from the working group, the benefits are again extraordinarily large, anywhere from 90 to 1 to 400 to 1. Again, so large such that the benefits of fossil fuel utilization outweigh the cost so much as the costs are in the statistical noise. Next slide. All right, how viable are the estimates, both sides of the equation, the benefit estimates and the cost estimates? Well, Dr. Michael's already talked about the unreliability of the SEC estimates. I'll just second. Objective observers have said they're close to useless, but we've accepted those as published. How viable are the benefit estimates? I think they're believable and robust. They're backed up by over 200 years of economic history, thousands of study, and there are some direct benefits, as indicated from the IDSO slide, but the benefits are mainly indirect. They derive from fossil fuels which create CO2. Again, this is extensive literature verifies the critical role of fossil fuels in creating current technology, wealth, and our high standards of living. Next slide. Finally, in conclusion, CO2 benefits are extremely large compared to even the dubious IWC SAC estimates. The benefit estimates can be modified any way you wish. They can be scaled, adjusted, forecast, expressed as marginal values, expecting current dollars, constant dollars. The imbalance is such that they're still going to remain orders of magnitude larger than any reasonable estimate of the SEC costs, even if you accept what the interagency working group has done. Federal agencies are required to assess both the costs and benefits of regulations. Okay, against President Bill Clinton executive order. They have to do that. To do it legitimately, you have to look at both the benefits and the cost of a proposed action or regulation or mandate. The bottom line here, which I hope you take away with you, policies designed to artificially reduce fossil fuel use will do much more harm than good and should be avoided, even if the policies are indirect, such as using these bogus SEC estimates in proposed regulation. What we're talking about here, this is an empirical fact. It's a truism, even though to some it may represent an inconvenient truth. Thank you.
I think the co-author, and I'm actually the lead author of our comments on which my talk is based, Kevin Diaratna, is here, and is going to be handing out some charts. I won't be using PowerPoint. You can have these to distract you while I'm trying to talk. And usually I have nice, funny pictures that I use in my presentation, so I'm really hoping you did not have decaf this morning. The social cost of carbon is a measure, supposedly, of the incremental damage that an additional ton of carbon emitted will do over the next 300 years, if you're looking at the calculations made by the EPA in their social cost of carbon estimates. So you get a different social cost of carbon for each year. All right? What they say is, suppose we don't do anything about carbon emissions, and we emit one more ton or one fewer ton in 2020. Okay, how much difference would that make in temperature change in 2021, 2022, 2023, boom, 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 out to 2300? Then they say, okay, with that temperature change, how much difference will that make in GDP and sea level rise, and what kind of economic damage will that cause. And as has been pointed out, that's, should I be talking to this one? Does that work? Okay. As has been pointed out, the damage function, that is, the function that translates sea level rise, temperature increase to economic losses, is totally bogus. I mean, the argument should be done at this point. We should say there is no justification for using the social cost of carbon calculations, because right now it's just an academic exercise. If we knew what that damage function was, if we knew what the impact of warming was, then this might be a cool way of calculating the social cost of carbon. We don't even know if it is damage or benefit. Okay, and I'll show you that in a little bit. What you have before you, if you start in the front, it says comments on the social cost of carbon, and Kevin Dyeratna, who's passing this out, is the mathematician modeler that we're very lucky to have at Heritage. In fact, we should, those of you that are conservatives should be glad he's on our side. We have run the EIA energy model because Kevin can do it, and then when we're looking at the social cost of carbon, we got 2 of the 3 integrated assessment models on which the EPA social cost of carbon estimates are based. The third model, the Chris Hope's Page model, is proprietary, and he insists on having the right to be a co-author on any publication using it. So that seemed like a totally unreasonable burden. So we're just doing the other 2, the fund model and the DICE model. The first one we ran, it runs faster, is the DICE model. That's William Nordhaus's model up at Yale. It's one of the 3, again, that the EPA uses. We were pretty able to replicate the EPA's results. All right. So again, let me emphasize, the whole thing should be shut down because of the damage function, but the EPA seems to be totally immune to that reason. So we're saying, okay, if you're still going to play with this model, let's look at what happens when we make reasonable adjustments to a few variables, and in some cases, a mandated adjustment to a few variables. For instance, the EPA has been noted only use 3 discount rates, 2.5, 3, and 5. The OMB mandates that you use 2 discount rates, 3 and 7, to bracket the damages and costs and benefits. Okay. They allow you to go outside that if you can make a case. All right. So the EPA did not use the 7%, the Intergovernmental Working Group didn't use the 7%. We can see what happens if you do use the 7% to one of these models, and you would have similar impacts. So if you want to look at that first table, and we can look at discount rate 3%, which is the one that they mainly focused on, in which they generated their social cost of carbon, that is the group, and look at the discount rate for 7 and see how much it changes. For 2010, it goes from $30 down to $4. For 2020, it goes from $37.79 down to $5.87. Okay, so this is close to an order of magnitude change. And the 2050 value is from $61 to $12. That's huge. What does that say? All right, if they had used one of the 2 discount rates that they were obligated to by the OMB directives, all right, there would have been a factor of almost 10 in the difference between the values. Would have dropped by 80-some%. Okay, factor of 5. All right. So that's just one variable that we changed, using the one discount rate that they were obligated to use, which they didn't use. It makes you wonder why they didn't use it. Now, let's talk about that discount rate. There's been a lot of intellectual gymnastics to push, I apologize about that, to try to justify what I consider ridiculously low discount rates. And what you'll see is the lower the discount rate, the greater the weight is placed on future costs. Okay. One of the arguments is, well, we shouldn't be using a rate of return on capital because we're changing consumption here and consumption there. And if you're changing, that just doesn't make sense to me, because if you're using consumption, if you look at what the interest rate they're paying to consume earlier, it's much greater than rate of return on capital. So you should use a higher discount rate. They fall down, they say, well, what we're really looking at is we have, in essence, a social welfare model. We're saying how much wealthier are people in the future, which they acknowledge, and how much less valuable is another dollar to a wealthy person. That's the only thing that should count, and that's where you get these arguments for 1% and 2% discount rates. It just don't make sense. One of the strongest ones, and it even was in Science last summer, there's been a literature since Martin Weitzman of Harvard published his paper on how should we discount the far distant future. And he came up with a very sophisticated model with a totally counterintuitive result that is totally counterintuitive because it is wrong. All right? And when something is that bizarre, you really have to look at it. But his math is so sophisticated, I think the vast majority of policymakers and even economists didn't really work through it to see what he was saying. It starts out as nominally reasonable. All right? Suppose we don't know what the discount rate should be for the next 300 years, which is a pretty good assumption. All right? For instance, suppose it could be 1 or 7% with equal likelihood. And this is the example they used in Science magazine. What they do is they say, what's $1,000 in 300 years worth today? At 1%, it's about 50 bucks. If you discount it at 7%, it's 0. It's 0.0000, I don't know, 5 or 6 zeros, 1.5. All right, so it's nothing, okay? They then said, what if there's an equal chance of there being a 7 or 1%? Then we average 0 in with 50, we get 27, 25, okay. It sounds like what they're saying is there's an equal chance of 1 in 7, and so you get this, and so we should really be using something closer to the 1% discount rate. What they're saying is we have two possibilities. It is 1% for 300 years straight, or it is 7% for 300 years straight. Now, if there's an equal chance of it being 1 or 7% for each of those 300 years, all right, there are the odds of it being one of those for 300 years straight is 2 times 10 to the minus 90th, minus 90, okay. So they have taken two extreme cases, each of which is almost certain to not happen, and taken an average of that. In order to get this $50, in order to get this $50 present value from this exercise we're talking about, where there's an equal chance of 1 or 7% being the legitimate thing, you have to have it be that 1% for 300 years, all right? To get that present value of $1,000 in 300 years to be as high as $1, that 1% discount rate has to hold for at least 232 of those 300 years, all right? The odds of that, if there's an equal chance, is 10 to the minus 22, okay? Just not gonna happen, okay? What do they then do? In order to try to get themselves out of this horrible mess that is simply their model's going to collapse, they say, well, it's possible that we could have correlated discount rates. If you get into a slow growth mode, it might just hang around. We don't know what the future is going to be. It's almost like we've already invented everything, so we can't have growth anymore. You know, the predictions that have been made for centuries. But let's just say maybe, okay, maybe that's going to happen. What sort of world would we have where the discount rate would be as low as 1? Well, let's go back 2 centuries, okay, and see. From 1802 to 2002, the real rate of return on the stock exchange in New York was 6.8%. Okay, so that would be the opportunity cost of capital for the past 2 centuries, about 7%. Okay. What was the growth rate in the US? The per capita GDP growth rate for those 2 centuries was, let me have it down here, 1.55%. Okay, so keep that in mind. 1.55% per capita GDP growth rate corresponds to a 7% opportunity cost of capital. All right. Now, the world growth rate was even slower. It was 1.1% over those 2 centuries, and I get that from Angus Madison's amazing project. Okay. What are the projected economic growth rates in the models used by the EPA? All right. Now here we have, it's a bizarre sort of situation. The greater the economic growth, the richer people are in the future, the more damage you're going to get from a percent change in GDP. So you have what may be counterintuitive, that the richer people are in the future, the more growth we have, the higher will be the social cost of carbon. Okay, so what will you then, so you're going to have these bigger, the faster the growth rate, the faster the economic growth rate, the bigger the future damages because you have a bigger pie that you're mucking up. All right? If that's true, you cannot then say, we're going to use a discount rate that corresponds to a world that's stagnant. And that's exactly what they're doing. All right? If we have a stagnant economy, we're not going to have huge damages in the future. You need to align the economic growth rates with the opportunity cost of capital and consequently the discount rate you're going to do. The EPA did not do that. The arguments that Weitzman makes and his whole literature totally ignores that. They say, let's pretend we're going to have fast economic growth. Let's use a discount rate that corresponds to stagnant economic growth. Okay. That said, let's look what happens when you use a more reasonable one. I think 7% should be the minimum discount rate. I don't think it should be the high end and the low end, then we pick something in the middle. All right. Opportunity cost of capital corresponding to a lower economic growth rate than they have in all 5 of their economic models in the integrated assessment models is significantly higher. So it should be more than 7%, but let's just look at what happens. So for the DICE model, we saw using just the 7% discount rate drops the numbers by about 80%. They also came out, they used these integrated assessment models. It's funny, and maybe Pat talked about this. There was a window where some people were making a legitimate case that sea level rise was going to be much faster than had been in the previous IPCC report and in previous literature. You know, instead of the 7 to 23 inches, it might be as high as 36 or more inches. Right? That was the what was it? The semi-empirical modeling, something like that. Since then, that's pretty much been trashed. We're back to the low ones. Okay. So there's this window of opportunity where they could force the integrated assessment models to use a higher sea level growth. There was also at that time available, all right, lower, newer, better estimates of the equilibrium climate sensitivity. That is how much a doubling of CO2 will raise world temperatures. They ignored that, used the older, higher one. So to me, there's clear cherry picking going on here. Anyway. So what if we used a shorter time horizon, for instance? And if you look at the second table, you can see that that really has an impact on the lower discount rates. Because if you say, let's say let's not pretend we can do economic impact studies for 300 years. I mean, no, come on. You know, we've missed every turn in GDP in the past decade. That drops it dramatically. What if you use the newer equilibrium climate sensitivities, it lowers it even further. So that's the DICE model, what we see there. Okay, so what I've done is I've tried to make an argument that 7% is a much more reasonable discount rate than 2.5, 3, or 5. Okay, and if you use that, not only is it more reasonable, but it's mandated by the OMB. All right, you get the social cost of carbon drops by 80%. You can drop it another couple of bucks if you say, why don't we just pretend we can look out to 2150? You know, why are we pretending we can look out to 2300? Do we really know how to help people 3 centuries from now? I often think, what if we go back 3 centuries? You know, what would we have wanted our ancestors to do? What would we have wanted them to give up? What would we want them to do for us? You know, when they thought they were doing a public good, it was draining swamps, all right, with going on crusades or things like, I mean, things we think are horrible now. Okay. Why we think we're going to be so much smarter that we can help our descendants who will be much richer, much smarter 300 years from now. Now let's look at the fund model. Flip the page over. All right, I think maybe we should do jumping jacks now to get get things going. The fund model is the only one that explicitly allows for a negative social cost of carbon. But that means there is a benefit of carbon. There's a benefit from warming, there's a benefit from CO2 fertilization, which we just saw examples of. Okay? The fund is the only one that does that. What did we do there? If you add the 7% discount rate to the fund model, that's all. We're not messing around with a damage function that we think is totally bogus. Okay. Well, now you don't even know what the sign is going to be. For the first 3 decades, the sign of the social cost of carbon is in fact negative. Okay. If you use the new equilibrium climate sensitivities from Otto et al., by the way, the authors, Otto et al., includes, most of them are ICC authors as well, ICC report authors. Okay. ICC, Intergovernmental Climate Change. IPCC, thank you, not the Interstate Commerce Commission. So they line up. These can be called denier scientists, all right, or even skeptics. Okay, and I would call skeptic as a synonym for good. But anyhow, like Pat here, whose predictions 10 years ago, it turns out, are pretty much right on line, and the global warmists are really embarrassed because every time they adjust theirs, they get closer to what Pat said 10 years ago. But in any event, so Otto et al. Are getting closer to what the truth is, closer to what Pat said 10 years ago. We use that equilibrium climate sensitivity, the estimate of how warm it will get for a certain amount of CO2 emissions, and the 7% discount rate. What happens? It's negative all the way down. All right, we should be subsidizing coal. All right, now Heritage is not going to come out in favor of subsidizing coal. All right, we still like free markets. But that's what this tells us. If you believe these models, then this says we should subsidize CO2 emissions somehow because it fertilizes the crops, because warm is actually better for a lot of people. All right. Now here I think is the best of the tables. All right, and this was, as was most of this, Kevin's idea and Kevin's work. He said, what if we look at what's the likelihood that the social cost of carbon would actually be negative in the fund model? Because when you're looking here, you see little tiny negative numbers and big positive numbers. You say, well, shouldn't we average them up? But the distribution is not your normal symmetric distribution. It's kind of bunched up on the low end. Even at the 5% discount rate, for the year 2010, the odds using the fund model and the Otto et al. Distribution, all right, the newer, better, all right, distribution, the one that's more likely to be true, because it's had more recent data, it's averaged in this pause that we're seeing. It's about 50-50, okay? And again, why is that? Because most of the benefits come early, the costs come later. So if you have a higher discount rate, you're not giving that higher discount rate won't weight the future as heavily. So we go to 7%, and it's overwhelmingly negative. 70 to 50% as you go down the column there. All right, the odds are CO2 emissions are good. That's what this tells us. Now, I'm not going to try to make that case. Others have made it. The case I'm trying to make is these integrated assessment models are totally useless for making policy. We don't even know the sign. It's possible that we could spend trillions of dollars in the economy to reduce CO2 emissions, and those reduced CO2 emissions are actually a bad thing. All right? So we're spending money to make a bad thing happen. All right? That's what the negative social cost of carbon policy would tell you. Okay. Well, that's pretty much it. Okay, the main point, the integrated assessment models are useless. The social cost for making policy, interesting academic exercise. Social cost of carbon bounces around. We don't even know what the sign is when you make reasonable adjustments in just a few variables. So this should not be used for policy. Thank you.
Thank you, gentlemen. Those are 3 great presentations. It validates for me my initial assumption coming into this event, which is the assumptions matter, and the data that goes into these projections is largely speculative at best. So we are open for questions from the floor. Please, if you do wish to ask a question, just raise your hand, and my colleague will bring this microphone around for you so that your question can be recorded for the video. I will use my prerogative as the host, though, to start out the question session by asking this to all 3 of you, which is if you had the opportunity to talk with a senior policymaker about this particular subject, someone who's probably not versed in the integrated assessment models or the discount rates that are being worked into this analysis, what's the 30-second takeaway that you would want that person to have such that you could leave the impression of the totality of the work and the presentations that you've made here today?
Since I'm still warmed up from talking, I would say first, the evidence shows we're not heading to a catastrophe. All right. Second, even if we were, the policies that are proposed do nothing to ameliorate that, and they cost a whole lot of money. We don't know what the biggest challenge of the 21st century will be, but we know we'll better be able to handle it if we're wealthy. That's the best insurance policy.
I would say that it's incumbent upon any responsible policymaker to base policy proposals on defensible science. And I think what's telling is the fact that the climate models that form the core of the United Nations Intergovernmental Panel on Climate Change's most recent report have demonstrably failed at the 0.05 level. And in fact, when you run them backwards, they've been failing since 1976. That's really quite remarkable because we had a warming from 76 through 98. The fact of the matter is that rate was so modest that if we even go back to the beginning of the second warming of the 20th century, which is 1976, the models have failed. I don't see how anybody could justify costing people money based upon something that is so demonstrably false.
Roger?
I would say that fossil fuels from which CO2 derive are providing and will continue to provide immense economic benefits not only to the U.S. But to the world. And we should not try to artificially penalize the use of fossil fuels, especially on the basis of these SEC estimates, which are entirely bogus. Because as I said in the conclusion of my presentation, that the suppression, the penalizing reduction of artificial reduction of the utilization of fossil fuels will do much more harm than good.
Thank you, gentlemen. Questions from the floor? No questions?
There's
Second Arlo or?
Yeah, there is a.
What?
There is a. Hello? Okay. There was just one thing I wanted to point out. The probabilities of the social cost of carbon being negative according to the fund model, those are based on summing the damages up to 2,300, and it's still incredibly negative. If you summed it up to 2,150 or like a less unreasonable year, you would have even a greater probability of a negative value of the social cost of carbon. That just shows how useless these models are.
Thank you.
Hi, Marlo Lewis, Competitive Enterprise Institute, and I was trying to think of what someone from the IWG, the Intergovernmental Working Group, might say in criticism of our criticisms. And one of them is that they would say, well, look, the social cost of carbon deals with these costs that are imposed on third parties that are not reflected in the prices that we pay for energy, even at the gas pump or the utility bills. And Roger has presented some fabulous information about the indirect economic benefit of each ton of CO2 emitted. But I would argue, in response to those critics, that on top of the economic benefits, which can be reasonably measured directly, how many dollars of GDP is supported by this ton of carbon, that there are phenomenal social benefits of carbon that are on top of those. For example, if you look at food production, which of course would be practically medieval levels if we didn't have fossil fuel, and we'd have billions of people starving to death. What is the social benefit of one meal that saves one life? It's much greater than the cost of the food or the income to the farmer. And so there, on top of the immense indirect economic benefits, there are just these gigantic social benefits. In fact, I think Roger actually gets to this, that progressive civilization as a whole is this phenomenal, immeasurably large public good. And that is to a great extent, a social benefit of carbon. And so if anyone would care to comment on that line of argument, I'd be very pleased.
Well, just a quick comment. We hear a lot about externalities, and as economists, we're familiar with what an externality is. And they like to talk about the negative externalities of fossil fuel production, carbon emissions, pollution, etc. There are also positive externalities. For example, if you're talking about replacing all U.S. coal plants with windmills and switchgrass and solar panels and that, the cost of electricity is going to double, triple, quadruple, even if, assuming it's physically possible. So when people's utility bills increase by a factor of 2 or 3 or 4, what are the social, economic, health implications of that? We know what they are. There's been numerous surveys. When people can't afford their utility bill, they stop buying food. They stop taking their medicine. So you have to. If the end you're looking at externalities, there are indeed negative externalities. There are also positive externalities.
Let me just make one comment that feeds into this. In the integrated assessment models, they have 5 different scenarios for economic growth. Only one of them is called optimistic, the emerge optimistic. And why do they call it optimistic? Bizarrely, because it has the lowest growth rate. And therefore you're less likely to have the climate damage. So the worse off, the closer we get to caveman, apparently the better we are.
Along those lines, I would just point out that it's very easy to pick up USA Today, their writer, Mr. Rice, or any of the major legacy media publications, and you read how many people global warming will kill. There was a piece in Nature magazine that came out in January that the Daily Mail had a huge headline that New York City will be uninhabitable by the year 2045. Now, I would argue that even if you warmed up the temperature 15 degrees, which would give New York City the climate of Miami, all you would have done would be to spare them the cost of moving in their declining years, where they're going to move anyway. But here's the point. They never talk about how many lives were saved. Well, I can tell you. I can give you a rough estimate. In the industrialized democracy world, lifespan doubled, roughly between the year 1900 and the year 2000. Now, if you count the number of people who essentially had their lifespan doubled, works out to about 1 billion or so. That's like saving 500 million lives. That's the benefit side of the society that was powered by fossil fuel. You never see that calculation, but it's real. Thank you.
Final question, sir?
Well, this goes to David Kreutzer. You talked about the damage function in the context of the prior comments and questions. Could you repeat what you said about the damage function or functions that underlie the calculations for the social cost of carbon, and how they come up with that, and how it relates to this popular view that we have these greenhouse gases warming things and sea levels rise, and then there's this tipping point. And
the damage functions are a combination of some estimates of, say, warming's impact on corn production, which would be reasonable if that were the whole basis of it. At least it would be theoretically defensible. It also includes expert surveys. How much do you think 2 degrees of warming will do? How much damage will it do to the economy? And then sometimes it's just we assume that there's this, like Chris Hope's page model. It's alpha times t to the n, where t is the temperature change over the period. Alpha, we don't know what it is. T and the exponent for this very critical variable. And in one of his papers, he actually wrote, there's essentially no literature to address what n should be. So we made it even bigger than we did when we did the Stern review because it seemed more reasonable to us. I mean, so that's how arbitrary it is. Okay.
I'd like to send people home happy by killing the apocalypse. Precisely the argument that was made in the previous question is the linchpin for the need to cook up bogus social costs of carbon because we have to save the world from certain disaster. And the certain disaster that has been pushed by the extremists is that sea level will rise very rapidly. Sea level rises very rapidly because there's one place on the Earth where there's an awful lot of land ice, and it looks like it's awfully far south. That would be Greenland. If you take all the ice off of Greenland, you would get a sea level rise of about 23 feet or something like that. Well, you know, we actually very recently ran the experiment. It was in a paper that was in Nature magazine. It didn't get very much publicity, aside from the people who actually read it. And I want to tell you what it did, because this is the end of the apocalypse. Dorothy Dahl-Jensen from the University of Copenhagen, I think their Ice Research Institute or something like that, Polar Research Institute, drilled an ice core in Greenland, northwestern Greenland, got down to the bottom of the ice core. And you can date. Every year there's a melt, so you can count down number of years. She got to the Holy Grail. She got past the Eemian. What is the Eemian? The Eemian is the warmest period in the last interglacial. It centers around 118,000 years ago. Now, trapped in the ice is oxygen 18 and oxygen 16, which gives you an estimate of the temperature at which the snow initially was deposited. And also there's an isotope of beryllium, which measures the altitude at which the snow was deposited. In other words, the height of the ice cap. Well, it was thought that the Eemian, which is 6,000 years long, 6,000, okay, was 2 to 4 degrees C warmer in the summer than, say, the pre-modern temperature. That turns out to be wrong. It was 6 to 8 degrees C warmer. 6,000 years. 6 times 6, that's 36,000 degree years. There is no way that human beings can do much more than a few hundred degree years if we burn every bit of hydrocarbons that we could find. So anyway, now here's the cool part. The beryllium tells you how high the 11,000 foot deep ice was during that period of 36,000 degree years warming. According to Dahl-Jensen, the height of the ice was between, I'm translating in English units, about 1,000 feet lower than it is now, or 500 feet higher. That's minuscule. I hate to tell you, reality, and that core is real, has killed the apocalypse.
Thank you all for joining us today for this discussion. The comment period at the Office of Management and Budget on this social cost of carbon closes today. So if this presentation's inspired you to write some comments, you still have time to weigh in your government's decision-making process. Please join me in thanking the panel for being here this morning, and thanks again.